let's dive right into this explainer. You know, the human jaw can literally exert over 200 pounds of force. Just think about that for a second. Surviving that kind of daily, repetitive pressure requires some truly fascinating structural engineering. Have you ever looked at a perfectly restored smile and wondered exactly what is holding it all together beneath the surface? Because it's definitely not just a tooth glued onto a post. It's a highly sophisticated, multi-stage architectural process. So today, we're going to unpack the hidden microengineering that happens right inside the mouth.
So before we really get into the weeds here, we've got to define our unsung hero, the abutment. It's essentially the absolute crucial foundation piece in your dental architecture. You've got the implant root, which is surgically placed deep into the jawbone, totally hidden from view. And then you have the crown, right? The beautiful, visible part that looks exactly like a natural tooth. Well, the abutment is the highly engineered mechanical bridge that securely locks those two completely different worlds together. Without it, that flawless smile just wouldn't work.
Just look at this diagram. It's basically the ultimate decision tree for a clinician. Because replacing a tooth isn't about grabbing some one-size-fits-all part off a shelf. They have to navigate timing, shape, connection mechanics, and materials. They are literally mapping out every single engineering decision and customizing the approach for every individual patient before they even build that smile.
So we're going to break this whole blueprint down into 5 key areas. 1. The unsung hero of implants. 2. The timing from healing to final. 3. Choosing design and shape. 4. Connections and retention methods. And finally, 5. The materials making your smile. Let's get into it.
Starting off with Section 1, the unsung hero of implants, building the foundation.
Moving right along to Section 2, timing, healing to final, the chronology of a smile.
Because keep in mind, building a smile doesn't happen overnight. It's really a staged process. We're talking 3 distinct steps based on timing. Step 1, that's your healing abutment. Placed right at the second stage of surgery, it sits across the gum line, and its whole job is to help the tissue heal and contour perfectly around the future tooth site. Then, Step 2 brings in the temporary abutment, which basically holds down the fort, supporting a provisional crown while the lab crafts the final piece. And finally, in Step 3, the clinician locks in the definitive or final abutment. This acts as the permanent base. So it's a literal chronological journey from healing to a fully functional smile.
All right, Section 3. Choosing design and shape, tailoring the blueprint. Now this is where it gets really interesting, because every single jawbone and gum line is totally unique, so clinicians have to make a major core decision here, stock or custom. With a stock or prefabricated abutment, you're getting something pre-manufactured. It's super economical, but you definitely sacrifice customization. But then on the flip side, you have custom abutments. These are patient-specific, precision milled in a lab using advanced CAD/CAM tech. Yes, they take more time and investment, but the aesthetics are way better. Plus, you get a much better emergence profile, which is really just a fancy way of saying the artificial tooth naturally emerges from the gums looking incredibly lifelike.
And sometimes, clinicians are thrown a curveball. Like, if bone density forces the implant into an awkward angle, they'll pull out an angulated abutment to correct that trajectory by 15, 25, or even 30 degrees to bring the crown back perfectly into alignment. Pretty clever, right? Or, if they need something totally unique, they'll use a plastic UCLA or calculable abutment to cast a completely customized metal piece. And for those times when they just need pure, unyielding strength, like for a screw-retained prosthesis, they'll go with a rock-solid, one-piece solid abutment.
Next up is Section 4, connections and retention methods locking it together.
So, we've got the root and the bone, and we have the shaped abutment. But how do we actually lock them together so they survive decades of chewing? Well, the engineering evolution here is just wild. It started with the external hex, literally a hexagon shape sitting on the outside of the implant. It's common, it's cost-effective, but it definitely has its limits. So engineers move the connection inside with the internal hex. This provides much better aesthetics, and it shrinks what's known as the microgap, that tiny space where pesky bacteria like to hide. But the absolute gold standard today? The internal conical, or Morse taper. This thing acts almost like a cold weld. It locks perfectly into place, giving an incredible seal and super efficient load distribution when you bite down.
And then comes the ultimate trade-off, cement or screws. How do we attach the final visible crown? A cement-retained abutment means gluing it on permanently. You get flawless, unbroken, but there's always that slight risk of cement residue irritating the gums. On the other hand, a screw-retained abutment fastens the crown with a tiny comes the ultimate trade-off, cement or screws.
how do we attach the final visible crown? A cement-retained abutment means gluing it on permanently. You get flawless, unbroken aesthetics, sure, but there's always that slight risk of cement residue irritating the gums. On the other hand, a screw-retained abutment fastens the crown with a tiny internal screw. From a maintenance perspective, this is brilliant. If something breaks, you just unscrew it. Easy retrievability. But, and it's a big but, the clinician has to perfectly hide that tiny screw access hole in the final tooth. It's the classic debate of pure beauty versus practical maintenance.
Which brings us to our final section, Section 5, Materials Making Your Smile. What is it made of?
Because what exactly are we putting inside the human body? The material science is literally just as important as the mechanical shape. Clinicians basically have a 4-item menu here. First up, titanium. It's insanely strong, perfectly biocompatible, and easily the most popular. But, well, it's gray metal. So if you need flawless, tooth-colored beauty right at the gum line, you swap to zirconia. It's stunning, but slightly more brittle. Then there's PEEK, this really fascinating tooth-colored polymer that actually absorbs shock and resists plaque. And finally, gold alloy. Incredible fit, superb biocompatibility, but yeah, you guessed it, it is definitely the most costly option on the menu.
So when you step back and consider all these options together, the timing, the physical shape, the mechanical locks, and the advanced materials, it becomes abundantly clear. Replacing a tooth is absolutely not a simple procedure. It's a straight-up masterclass in microengineering and careful, individualized selection.
Synthesizing this whole blueprint comes down to a delicate balancing act of 6 main factors. The clinician is actively weighing the aesthetics, the occlusion, your bite, the exact implant position, the health of your soft gum tissue, the type of final prosthesis being used, and of course, their own clinical preference. It is a massive, complex puzzle, and every single piece has to fit perfectly.
It really makes you wonder, doesn't it? Next time someone flashes a brilliant, flawless, artificial smile at you, I bet you won't just see a white tooth anymore. You're going to know about the invisible titanium foundations, those precision-milled angles, and all the hidden micromechanics silently holding it together. Kind of makes you think, what other engineering marvels are just hiding right there in plain sight? Thanks for joining me on this explainer. Keep looking beneath the surface, and